Hello aspirants. In our last lectures, we learned about different types of decomposition reaction. So today we are going to learn about displacement reaction. So without wasting time, let's begin with the topic. Displacement reaction. Let's see the definition first. So students, the definition is the chemical reaction in which an element or ion displaces or substitutes. The meaning of the displace means only substituting something. Other element or ion from a compound to form a new compound is known as displacement reaction. So we understand that a chemical reaction in which an element or ion yes, it can be both. I will show you how ion displaces. So it should be an element or ion and it will displace other element or ion from a compound to form a new compound, and that is only displacement reaction. Okay students, now see students, there are two types of displacement reaction. See students, the first one is single displacement reaction, which is also known as replacement reaction, and the other one is double displacement reaction. And in most of the books we will find the name of the double displacement reaction is also called as double decomposition reaction. In older days we call this double displacement reaction as double decomposition reaction only. Okay students, so don't confuse between double displacement and double decomposition reaction. Now moving on the next subtopic, that is single displacement reaction. Now see students, what is single displacement reaction? The chemical reaction in which highly reactive element displaces the less reactive element from an aqueous form of compound to form a new compound. The displaced element formed in a pure state and gets uncombined after the reaction. So students, the element should be highly reactive. Okay students, I will show you in the next subtopic on the reactivity series how we will know which one is highly reactive and which one is less reactive. Now let's see in this that the element should be highly reactive element, not ion. Ion should be in the double decomposition reaction, not in the single displacement reaction, and it will displaces the less reactive element from an aqueous form of compound. The compound should be in the aqueous form. And now you may ask that what is the aqueous form? Aqueous form is nothing but the compound is dissolved in water to form a solution, and that is only the aqueous form, and then after only it will form a new compound. And the element which gets displaced, it will be in a pure state and it will not combine with any other element or compound until and unless it gets reacted with other compound. For that reaction it will be uncombined and it will be in a pure state. Let's see the general equation for this single displacement reaction. It is A plus BC forming AC plus B. See, this A is highly reactive element and B is less reactive element. Since B is less reactive element, that's why it displaces B to form AC, and C, I told you B will be in a pure state, and it is in a pure state. How you will understand? Because it is uncombined. See, B is alone in this reaction after yielding the product AC. Okay students, understand? Now move on to the next subtopic, that is reactivity series. After the reactivity series only, I will show with an example that how single displacement reaction takes place in a chemical reaction, or else you will not understand. Okay students, let's see. Now students, what is reactivity series? The reactivity series is a way of ranking elements in order of their reactivity towards the substances in a chemical reaction, and it is always in a descending order, means from the high reactivity series we go downwards to the less reactivity series, and it is also known as activity series also. Okay students, and now there are two types of reactivity series. One reactivity series is with respect to metals, and other one is with respect to non-metals. And which non-metals? It will be always halogens, that is the elements in a periodic table that is present in the group number 17. Okay students, except halogens no other will be there in this category. Now let's see the reactivity series of metals first. Now let's see the reactivity series of metals. What it states? It states that the series is typically based on how readily a metal can lose electrons and form positive ions. Okay students, now let's see how the elements are arranged according to their reactivity series. It will go according to a descending order. Let's see. First is lithium, potassium, sodium. Now students, in most of the books you will get first potassium, sodium, then lithium. Don't confuse. Lithium is more reactive than potassium and sodium, so lithium will be placed always first before potassium and sodium. Then barium, strontium, calcium, magnesium, aluminium, carbon, manganese, zinc, chromium, iron, Fe, Cd, cadmium, CO, cobalt, nickel, Sn, tin, Pb, lead, hydrogen, antimony, Sb, bismuth, copper, silver, mercury, gold, platinum. Since lithium, potassium, sodium are more reactive, it is always placed in the first before starting of the reactivity series. And as the gold and platinum is the least reactive, it is always placed at the last of the reactivity series. Now students, I told that it is a reactivity series of metals. Now you may ask me that why I write carbon and hydrogen. See, for the hydrogen we make the reactivity series of metals according to the priority of the hydrogen, means the elements placed above the hydrogen are the more reactive than the elements placed below the hydrogen. So hydrogen is always in the middle part of these elements. Okay, now you may ask me that why carbon. See students, both the carbon and hydrogen has a tendency, maybe they are non-metal but have the tendency to behave like a metal in these chemical reactions. That means they can displace the other elements. See, carbon can displace iron or zinc, and hydrogen has a tendency to displace copper, silver. Okay, students, understand? Now the reactivity series of non-metals, that is halogens, only 4 elements, nothing that. First is fluorine, then chlorine, bromine, and at last iodine. Basically, in the chemical reactions, we take only 3 elements only, these 3: chlorine, bromine, iodine. Now you may ask me that why we don't take fluorine in the chemical reaction. Because fluorine is so much vigorous element and it has the highest electronegative number. Okay, student, and so much vigorously it reacts that it can happen a vigorous accident. So chemists don't, means in the lab we don't use fluorine to test something until and unless accidents happen, may not happen. So we take only these 3 elements. See, reactivity is decreasing towards the right side. In same case for metals also. Okay, students, now move with some examples. See, students, some example. See, zinc, it can replace hydrogen. Why? Because zinc is placed above hydrogen, so it will form ZnSO4 and hydrogen. When zinc reacts with FeSO4, ZnSO4 plus Fe. Okay, students, same with when calcium reacts with MgSO4, it forms calcium sulfate, CaSO4 and Mg. Okay, students, understand? See, calcium is placed above magnesium. Yes, right, that's why calcium can displace magnesium easily and forming the compound calcium sulfate. Okay, students, now see, students, some funda. Cation replacement. Means one cation replace another. How? Let's see. First, Fe. Take with the example of Fe plus CuSO4. It will form FeSO4 and copper as precipitate. Now this copper sulfate is also known as blue vitriol, common name for copper sulfate, and FeSO4 is known as green vitriol. Okay, students, now how the cation replacement take place? See, Fe is in the pure form and neutral, so it's 0. No anion or no ion is forming. In this copper sulfate, copper is in the state of +2. Yes, students, cation +2 and sulfate is -2. But after iron is reacting with copper sulfate, it is forming FeSO4. Yes, right, student. But here the change is, I told cation replacement, and cationic replacement is only taking place. Fe is forming +2, sulfate is the same -2, and copper is becoming 0. Now you may ask me that how? Yes, see, first of all, Fe is in the 0 state, that is neutral, and copper is in the +2 state. Yes, students. Now iron is donating electron. It will break down. This copper sulfate will break down into Cu2 plus and SO4 2 minus. Okay, students. And when this copper sulfate is breaking down, it is forming ions, that is, one is cation and another one is anion, copper ion and sulfate ion. And since these are in iron, iron will donate electron to whom? To the copper. Copper will accept the electrons from the iron. How many electrons will iron release? 2 electrons. Okay, students, and becoming Fe2 plus. This copper will take the electrons from iron and forming Cu. See, it is in the pure state. Yes, students. And after iron becoming iron Fe ion, what iron will do? Iron cation. Yes, students, iron cation will form a compound with sulfate ion to form FeSO4. Okay, students, this is only the cation replacement. See other examples also. When zinc is reacting with copper sulfate, it is forming zinc sulfate and copper. Same reaction, and this zinc sulfate is also known as white vitriol. What vitriol? White color, white vitriol. What will happen when zinc will reacting with FeSO4? Same we see in the previous example only. Yes, students, it will form again ZnSO4, and that is also in the white, because ZnSO4, the compound, is white vitriol. But what will happen when iron will reacting with ZnSO4? Students, it will not reacting. No reaction will take place. Why? Because iron is less reactive than zinc compared to a zinc. Because in the reactivity series only we see that Fe is placed below the zinc. Yes, that's why Fe can't displace Zn to form the compound FeSO4. Okay, students, so no reaction will take place. Now move on to the next category, anion replacement. See, students, what is anion replacement? Replacing one anion only. See, students, with the help of example, chlorine. When chlorine is reacting with sodium bromide, it is forming NaCl and bromine. Okay, students, now let's see how the anion replacement take place. See, same, chlorine is 0, neutral, sodium is +1, bromine is -1. But in the product side, sodium will be the same, +1, and chlorine and bromine, it will change each other. The anion cation, the anionic replacement will take place. Chlorine will be -1, bromine will be 0. The same thing, nothing else. Chlorine will accept the electron. How many electron? 1. It will break down into sodium bromide, will be break down into Na plus and Br minus. And since they are becoming the ions, it is easy for the chlorine to reacting with sodium bromide. Okay students, since this compound is in aqueous form, and in aqueous form always the salts break down into ions. These are only salts only, nothing else. So what sodium is doing? Sodium is releasing the electron. Yes, and what chlorine will do? Chlorine will accept the electron from the sodium and forming NaCl. And since, sorry students, sodium will not release the electron since it is in the ion only. Bromine will release the electron because to become the pure state it will release one electron, and chlorine will accept that electron to forming Cl minus. Yes students, and this Cl minus is only reacting with Na plus to form NaCl. Yes, and since bromine is releasing one electron, it will form Br. Okay students, understand? Br, then only it will forming the molecule Br2. Understand how the anion replacement takes place? Let's see the other example also of anion replacement. When bromine reacts with potassium iodide, it forms KBr and iodine. Okay students, but what will happen when iodine reacts with NaBr or NaCl? No reaction will take place because in the reactivity series of halogens, iodine is the least reactive than any other halogen. So iodine can't displace the bromine or chlorine. Okay students, understand the anion replacement? Before moving on to the next subtopic, please remember one thing. For the cation replacement, the cationic replacement will always happen with the metals only. Okay students, and the anion replacement will always takes place with the reaction of the halogens. Understand? See, halogen Cl2, and it is also the salt of halogen element only. Yes, but in the cation replacement we don't see such the halogen reaction. Yes, we see some metals such as zinc, iron, calcium. Okay students, copper. Understand? Please remember this thing. Don't confuse between cation replacement and anion replacement. Now students, let's see some common examples. First one is metal acid reaction. What happens? Metals react with acid to form salts and hydrogen gas. Let's see with the help of example. When zinc reacts with HCl, it forms ZnCl2, zinc chloride, and hydrogen as gas. When copper reacts with sorry students, not copper. When magnesium reacts with H2SO4. It forms magnesium sulfate and hydrogen gas. Okay students, understand? Let's see the other one, that is metal water reaction. Means the metal reacts with water to form a new compound. When iron reacts with water, it forms FeO and hydrogen gas. See, common example means daily application. See, this reaction is our daily basis application. How? In our house applications, most of the applications we have that is made up of iron, such as doors, window. Yes students, we have. Now when rain is occurring, after rain, or when the windows or doors get contact with the iron, we see rusting is forming. Yes students. Now what is that rust? That FeO, this compound is only the rust. Okay students, this compound is only forming. Understand? Now see other example of metal and water. When sodium reacts with water, it forms sodium hydroxide and hydrogen gas. This is the vigorous reaction and fast and vigorous, and also heat and light is occurring in this reaction. This one is the slow reaction, Fe plus H2O, but this one is the fast and vigorous reaction. Okay students, when calcium reacts with water, it forms calcium hydroxide and hydrogen gas. See, hydrogen gas is common, it will form as a gas. See, in metal acid also hydrogen gas, in metal water also hydrogen gas is in, and hydrogen gas is in the gaseous form. Okay students, see students, one example. I saw that Fe when reacts, when reacts with water, it forms FeO. This is the metal oxide. Okay students, metal oxide means oxygen is present in the compound which form with the oxygen and one metal, that is the metal oxide and hydrogen gas. And this is the metal oxide. This metal oxide when further reacts with water, it forms alkali, that is FeOH. Okay students, understand? Now you may ask me that in this reaction, calcium when reacts with water, yes students, is forming calcium hydroxide. See, the same thing like this. First of all, it will form metal oxide, and hence when it again reacts with water, then after it is forming calcium hydroxide. Okay students, understand? Now clear? These FeOH, CaOH, NaOH, these all are alkalis. Alkalis means the bases which can dissolve in water. Okay students, understand? Next category, metal extraction. Now I will show you how carbon is displacing the metal. See, ZNO when reacts with carbon, carbon here means charcoal, we use charcoal, and this zinc is an ore, zinc ore. We will extract the pure form of zinc metal. See, pure form of zinc metal we get, and carbon monoxide will form. Okay students, this reaction is also known as carbothermic reaction. What thermic? Carbothermic reaction. Now what is carbothermic reaction? The carbothermic reaction involves the reduction of metals. Okay students, as in reduce, it will reduce the metal with the help of carbon only, no other element except carbon, and carbon here acts as an reducing agent. See, it reduces oxygen to form zinc, the pure form of zinc. This is only a carbothermic reaction. The other example, such as when manganese oxide, when we extract the manganese, see how manganese is extract. Manganese oxide reacts with aluminium. It will form the pure form of manganese and aluminum oxide, 2Al2O3. Okay students, understand? Now see how silicon is extracted. And metal extraction, in metal extraction we mainly use metal oxides because it's easy to extract the pure form of metals. Okay students, see, when silicon oxide is react with aluminium, it is forming the pure form of silicon and 2Al2O3. Okay students, understand? See students, silicon is not a metal, it is a metalloid. Okay students, silicon is a metalloid. Metalloid means the elements which have the properties of both metals and non-metals. But don't confuse with the carbon. Carbon is non-metal. Okay students, understand? The next category, thermite reaction. What happens in this thermite reaction? In this reaction we mainly use of highly reactive metals as reducing agents. Okay students, which leads to exothermic reaction that melts the metal that is producing. See with an example only. We take iron oxide, another iron oxide, Fe2O3. When it reacts with aluminium, it is forming 2Fe and Al2O3. Okay students, this Fe2O3 is known as hematite, the common name for Fe2O3. So what happens when Fe2O3 reacts with aluminium? A vigorous exothermic reaction takes place, and since in exothermic reaction heat is producing, a huge amount of heat is released in this reaction, and since a huge amount of heat is released, the Fe iron gets melt down. Okay students, and forming liquid molten form of iron. And this is a daily application we see in the railway tracks when welding is done. By this process only welding is done. Okay students, understand? This liquid iron is only used. Showing you other example, when copper oxide reacts with aluminium, it forms Cu and aluminium oxide. Understand how the displacement reaction is in our daily basis reaction? These are the real life application. Understand? Now another real life application I am going to show you, that is silver tarnish. Now what is the word tarnish means? Tarnish is layer of corrosion formed over the metals. Okay students, showing you with the help of an example only. Let's see. When silver reacts with H2S and oxygen, okay students, these two are present in the atmosphere only. It will form 2Ag2S and 2H2O. See, it is the black color compound. Ag2S is in black color. We see that if we keep the silver open in an open area, after few days or months, we'll see that the silver is changing into black color. It is nothing but forming Ag2S. Okay students, now how to get back silver from this Ag2S? We will do reaction between Ag2S and aluminium, and it will form silver and Al2H3, aluminum sulfate. Okay students, understand? Now this is the example of silver tarnish. To keep the silver safe from becoming silver tarnish, we should always keep the silver items in the powder. Okay students, then only it will not react with oxygen and H2S to form Ag2S. Okay students, understand? Try to keep the silver items in the powder, means the talcum, talc we use in the daily basis, that talc only, nothing else. Okay students, the last one, halogen extraction. So we see the metal extraction. Now we will see how halogen is extracted. The common example is extraction of chlorine. Okay students, I will show you the industrial process of extraction of chlorine, how chlorine is extracted. A process is there that is used in industry, that is Deccan's process. What is Deccan's process? Let me show you with the help of an example. Chief use. Okay students, this is a chief use. HCl plus O2. Now here is the main funda. Heat is given from the range 400 degrees Celsius to 450 degrees Celsius, and a catalyst is used, that is copper chloride. This copper chloride is a catalyst, nothing else. And then after we will get 2 chlorine and 2 H2O. See, this is the industrial process for extraction of chlorine, and this process is also known as Deccan's process. Okay students, understand? Let me show you how bromine is extracted. Same reaction I will show you. NaBr plus Cl2, it will form NaCl, and Br2 it is released as gas. But here is a funda. This NaBr should be in the brine solution. Now what is brine solution? This NaBr is a salt. Yes students, this salt will be mixed with water to make the brine solution. Brine is nothing, the mixing of salt with water is only the brine solution, and after that chlorine gas will be ejected into that water, and then only NaCl salt will be formed, that is the aqueous form of NaCl, and bromine will be released as gas. Okay students, by this process only bromine is extracted, and same way iodine also. Okay students, understand? So for today up to this much. Hope you enjoy the video and understand this lecture on single displacement reaction. In our next lecture we learned about double displacement reaction or double decomposition reaction also. Same thing, the name is different. So if you enjoy this video, please like, comment down if any doubt is there, and you can send me topics also on which you want the video. Please comment me down, share this video with your friends, juniors also, and please don't forget to subscribe the channel Vivekananda Vigyan Charcha. Okay students, hope you enjoy this video. Thank you very much.